Hey students, Jim Eakins here. This video demonstrates what you will need to know before setting out on your snow science field investigation with the Confluence Project. With this background, you can get to snowshoeing and preparing your snow pit more quickly. Each snow science kit has printed instructions for each step in the snow science process. Instructors will be ready to help you with your snow science too. The instructors in this video are Mary Ingalls, Karen Trebitz, Marie Schmidt, and me. Sit back and enjoy the show. We will learn lots and have fun when we get out there into the snow.
So you need to be pretty aware of where those pits are, and please don't crowd the edges of the pit because you can collapse that pit in.
You know, we don't want to send anybody home prematurely, but just be really aware. If she's kind of standing right there, maybe I'm going to go this direction.
So on these snowshoes, there is a left and right, so find your left and right. And then you want the ball of your foot to go right above these spikes. And another way of doing that is to have your toe about halfway through this window. So you're gonna lay it down, you're gonna kick your foot in, and then you'll tighten the top two straps first. These are like snowboards, so you like ratchet them like that to get them tight. You pinch the red and white together to loosen, and then you'll do the heel strap last.
Grab that, give it a pull and pull backwards. Yeah. Pull back hard. You want it to actually stretch into that hole.
It takes some thinking to stay warm and dry in winter, especially when snowshoeing and digging snow pits. You don't want to sweat a lot because then you can get chilled when it's time to collect data. When you're working harder, either hiking or digging, remove a layer or two. If it's not snowing or raining, take off your outer shell or jacket while you're working for better moisture venting. When you slow down, put those layers of clothing back on to preserve the warmth. If you're going to play or roll around in the snow, be sure your shell is zipped up so you don't get snow down the back of your neck. Pay attention to how hard you're working and shed or add layers as necessary. It is an important winter skill that you can get good at if you're paying attention. If you get really cold or wet, let an instructor know. We'll have some extra dry sweaters and gloves that you can wear. Next, before you get to the snow, you need to be in groups of 3 or 4, and everyone has a job. Everyone can help shovel, but 1 or 2 lead shovelers is in charge of constructing the pit. Shovelers will also collect the data. The scribe neatly writes down the data. The gear boss is ready to hand measuring instruments to the data collectors and ensure nothing is left behind. The scribe creates a blank data table while the shovelers create the pit.
And you don't want just a steep, straight down pit. What happens if this kind of collapses on me and I'm trying to scramble out? To make it so that you can get yourself in and out. You will be climbing in and out several times. You might as well make it easy on yourself.
Where's the sun?
I don't know.
In the sky.
Look around you a little bit.
Up over there. Good.
So what's wrong with my pit?
It's facing it.
Yeah.
So
So the sun is there.
Yeah.
Direct sunlight is going to change the character of the snow really fast. All right? So you should be having the sun on the other side of the pit. In other words, your pit should be facing that away.
Some width. You can't just make a little skinny, you can't just go, don't be minimal about it. You can't do everything you need to do with a little pit like this. You want that pit to be, what, 1.5 meters or so, which a meter is pretty much like a yard, okay? Here, see if you can probe around over there. Just kind of over next to you there, just as a demonstration. You can push that probe all the way to the ground. And if you feel a stump or a rock or a bush or something in there, then maybe you want to move over just a little bit, because that's just going to get in the way of your digging. It's going to make it harder, and it's going to be harder to collect data. Leave one of those probes kind of on the ground and use that as a way to help mark where your face is going to be. Because it can get really easy if one person thinks this is the face and then one person thinks this is the face, and you're throwing snow up over here, that's going to throw off your measurements and stuff. So have that as just a physical reminder.
The other thing is I dug all the way to the grass. I'm all the way down here. All right? Once I'm down here, first thing I do is measure the total depth of my pit. We have 174 centimeters.
The slope meter has a little metal ball that rolls along this kind of curved track. Set the slope meter on top of the snow, sort of sideways to the slope. The metal ball will settle in the track so that you can read the slope, printed here on the front.
What do I do with this? I just chuck it, right? No, I take it, I put it back into the plastic bag. You want to really shave the face of this pit down very carefully. Use the card if you need to. You can use a little brush to help you determine where the layers are.
One other thing you guys can do when you're cleaning up that wall, when you put your shovel in, put your hand on the face of the shovel as you go down, and that will help smooth it on the way down. Yeah.
You need to mark your layers. Can you guys see the layers?
Yes.
So up here you can really clearly see it. Look at this. There's a layer.
Yeah, I see it.
Right? Here's another layer. So this top, this is the soft, fresh snow, right? Then here's a little bit harder layer. There's another layer. So we're marking these layers. This is the first one, second one. Sometimes you can see them. Sometimes you have to feel them. Oh yeah, that's a real hard layer. And you're working your way down. I feel another different layer here. There's one. And you're going to work your way down the whole face. What was this? That was a big snow. When did we have that one?
When you guys are identifying layers, what you're looking for is where the snow character changes. So does it change from really soft to really hard? Does the crystal type change dramatically? The other way to do it is to take the crystal card, the black metal crystal card, and to slice through the face of the snow, and you'll see where it stops. You'll start to see different layers, and you can feel.
We're going to measure every one of these layers. You can just fold this guy up and start from the top. We're going to go from the top down. So pit layer number 1, and you may have to put extra numbers because we may have more than 10 layers.
5 centimeters.
6 centimeters, right? Our next layer would be 5. Our next layer would be 10. So it doesn't matter how many it is. Just go through and measure them all to the ground. Fill that information. Be done with it. Fold this guy up. Put it away.
So once you get all these pit layers identified, we're going to go through and characterize some of the different features of each of those layers.
I already put the thermometer in the wall because I wanted it to be snow temperature, not me temperature. All right? So each layer, I'd like you to measure the temperature because I want to see how the temperature changes through the snow. If today was a really warm day, you might actually be above freezing up here. You might get really cold in the middle of the snow column, and then it gradually warms again until you get to ground surface, which is usually right around 0.
These are just big syringes. They're 100 cc. What's a cc again? Thanks. Cubic centimeter. So we have a known volume. Gotta push that through. Make sure that it reads to 0 when you have the bag hanging on there. We call it a tear weight. It says 0. So we'll set this aside. Now you could do this with any volume in here. We recommend just do it at 100. Just open it up to exactly 100. The same thing. We'll put this into the snow.
So if you tilt it up or down, Jim, it helps a lot.
So now I have a known volume of snow. We are going to extrude the snow, I love that word, into the bag, all of it. And now we have 20 grams of snow. If this was 100 cc's of pure water, what would that weigh?
How about 1 centimeter cubed of water? 1 gram. 1 gram, yes.
So if this was full of pure water, this would weigh 100. Now this isn't. This is 100 cc's and it weighs 20. So what percentage of water? It's like 20%.
So guys, you're going to do this for each layer.
What if it's a really tiny layer? How do you do that? Yeah, tiny one. How do you?
Yeah, you try to go sort of sneak it in there.
Oh, that's not very good.
Welcome to science.
Welcome to science. What do you guys think happened on this layer?
It rained.
You got it.
You got it. It rained.
Wow, genius.
If you can push your fist into the snow, that is characterized as very soft, right? Fist, 4 fingers, 1 finger, you guys will have a pencil, but if you get past the point where a pencil can go into the snow, we're gonna consider that to be very hard. If you were to put your fist on your nose and you push hard enough till it just starts to hurt, that's the kind of pressure that we're talking about. If you can't put your fist in the snow like that, then you switch to 4 fingers. If you can't put 4 fingers in, you switch to 1 finger. If you can't put 1 finger in, you switch to a pencil. So crystal structure takes a little while. What you're gonna do is there's a paintbrush in this kit and you have a crystal card and you basically brush some of the crystals out onto your crystal card and you can look at them with a little magnifying glass that's in your kit.
So these little magnifying glasses are pretty cool. They kind of fold out and then you can set it there and you can really describe the nature of the crystals that you get. And let us know if you have any questions. Let me tell you something with science. We don't expect you to grab everything the first time. We are both PhD students. We both do research. We have advisors. And in fact, we have teams of advisors who we go and ask questions all the time. Don't hesitate to ask us or anybody else questions. It's totally cool.
Okay,
What else?
have we talked to you guys enough yet?
Yes. We're bored.
Okay, fantastic. Why don't you guys head out and find a spot and start setting up your pits?
Hey, thanks for watching. Remember to ask questions and pay attention to what you're doing. From all of us at the Confluence Project and the Idaho Youth Water Summit, have a great day.
Of endless wanting, my heart wants we're gonna fall, 'cause we're lost. Oh, no, lost, so long.